Okay, I would like for you to make corrections on your quiz. You can use this video and go to the right part of your quiz to see which problems you missed and how to do them correctly. But this would be the key for your quiz. And I'm just going to do each problem and talk you through how to do each problem. So if you missed any, you can go through them right now as we go through this video. First of all, 7 to the 0 power. Anything to the 0 power is just 1. That's 2 points. Second part on your quiz here, try to get it so it's clearer. 6 to the negative 2. Anytime you have a negative exponent, that's going to be 1 over 6 to the second as a positive 2. But then 6 to the second is 36. So that is just 1 over 36. Number 3. Similar idea as number 2, but we have a negative 3 as our exponent. So I'm going to put that in the denominator and write it as 1 over negative 4 to the positive third. But negative 4 to the positive third means negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4 is 16, and 16 times negative 4 is negative 64. So number 3 is 1 over negative 64. Let's take a look at number 4. Okay. Number 4, 5w to the third, and then we have x to the negative fifth. Well, the 5w to the third, there's nothing wrong with that. We can keep that where it's at. But x to the negative fifth is going to move to the denominator as x to the positive fifth. Y to the negative fourth is going to move to the numerator as y to the positive fourth. So it looks like that for number 4. Number 5. 4 to the negative second, we would write that as 1 over 4 to the second. And then we have an n to the fifth, but m to the 0 is just 1. So I could put times 1 up on top, but it's just going to be 1. My final answer is going to look like this. N to the fifth, because 1 times n to the fifth is n to the fifth, over 4 squared, which is 16. So it's n to the fifth over 16. Take a look at number 6. We want to write this in scientific notation, which means the decimal would have to go here between the 4 and the 6. It's going to be 4.6 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. Number 7. We want to put the decimal point here. In other words, 3.27 times 10. In order to get it back here where it's supposed to be, we're going to have to move it to the left 1, 2, 3, 4 spaces, which is times 10 to the negative fourth. Number 8, 72 10,000ths. Well, in standard form, 10,000ths, this is the tenths place, the hundredths place, the thousandths place, and the 10,000ths place, which means 72 has to end in that place, which means in standard form it's going to look like this, but we want to write it as 7.2, but then I'd have to move the decimal 1, 2, 3 spaces backwards to the negative third. Let's take a look at number 9. We have 5.206 times 10 to the 7th power. That means we're going to move this decimal 1, 2, 3, 4, 5, 6, 7 places, which means we're going to have to add some zeros. Here's 1, 2, 3 zeros. It's going to be 52,060,000. Number 10. We have 7.1, but times 10 to the negative fourth means we're going to move this decimal 1, 2, 3, 4 spaces backwards, so it's going to be 0.00071. Number 11. We're supposed to put these numbers here in order, but in order to put them in order, we're first going to have to write them in scientific notation. The first one we're going to want to write as 8.09, but since I moved the decimal from here, right now it's times 10 to the 6th, which means I'd move it 6 spaces to the right. If I put the decimal here, which is where I want to have it, it's going to be times 10 to the 7th. I'd have to move it 7 spaces to the right. The second number is going to be 8.1, but this is times 10 to the 8th, which means we'd move it 8 spaces to the right. I'm going to want to put the decimal point there, which means instead of moving it 8 spaces to the right, I'm going to move it 7 spaces to the right. 799, the decimal is there. times 10 to the 6th means to move it 6 spaces to the right. But I would put it as 7.99. But then if I put the decimal point here, I'd have to move it 1, 2, plus the 6, which is 8 spaces to the right. And then 0.09, decimal's here, and I'd move it 8 spaces to the right. But if I put the decimal after the 9, which is what I'd want, 9.0 or just 9, it's going to be times 10 to the 6th power. So the very smallest of these numbers is the 9 times 10 to the 6th. And then we have a tie if we look at the exponents. So 8.09 is smaller. So it's going to be 8.09 times 10 to the 7th, and then 8.1 times 10 to the 7th. And the biggest number is 7.99 times 10 to the 8th. That's number 11. If we turn it over and look at the back of the quiz, if we look at the back of the quiz, it's going to look like this, which means I'm going to simplify number 12 by doing this. 6 times 4 times 10 to the 5th. There we go. That might be a little clearer, I guess. 6 times 4 times 10 to the 5th. 6 times 4 is 24 times 10 to the 5th. But in scientific notation, instead of having the decimal here and moving it 5 spaces to the right, I'd want to put the decimal between the 2 and the 4, but then I'd have to move it 6 spaces to the right. Number 13. If I multiply 4 times 3.5, again, we didn't use our calculator. 3.5 times 4 is 20. 4 times 3 is 12, plus 2 is 14. So 14. It would be 14 times 10 to the negative 6th. But instead of putting the decimal here and moving it 6 spaces to the right, I'd want it between the 1 and the 4, but then to the left, I'd only need to move it 5 spaces to the left. 1.4 times 10 to the negative 5th. Take a look at number 14. I'm going to multiply 4.2 times 5. 4.2 times 5 is 21. And then 10 to the 5th times 10 to the 2nd is 10 to the 7th. But that's not in scientific notation. The decimal's here. I want to put the decimal between the 2 and the 1, which means I'm going to multiply it I'm going to move it not 7 spaces to the right, but 8 spaces to the right. Number 15, if I take 8.1 times 2, that's 16.1 times 10. If I multiply 10 to the negative 3rd times 10 to the negative 4th, that's 10 to the negative 7th. But I'm going to want the decimal here, 1.61. So instead of 7 spaces to the left, I would move it 6 spaces to the left. And it would look like that. Number 16, if I multiply these together, 4 times 3 is just 12. But n to the 2nd times n to the 5th, I add the exponents, which is n to the 7th. Number 17, I'm going to multiply 5 times 3, which is 15. X to the 6th times x to the 2nd is x to the 8th, because I add the exponents when I multiply like bases. And then y to the negative 5th and y to the 3rd is y to the negative 2nd. But because that's a negative exponent, I can write it as 15x to the 8th over y to the 2nd. So my final answer is going to look like that. Number 18. I have 4n to the 3rd squared. Well, that means I'm going to take 4 squared, which is 16, and n to the 3rd squared. I multiply. When I take a power to a power, I multiply. That's n to the 6th. And number 19. X to the 4th, y to the negative 3rd squared. That means I'm going to take x to the 4th squared, which is x to the 8th. Y to the negative 3rd squared is y to the negative 6th. The second set of parentheses, I'm going to take 2 to the 4th. 2 to the 4th means 2 times 2 times 2 times 2. That's 4 times 4, which is 16. And then I'm going to take x to the negative 2nd to the 4th, which is x to the negative 8th. And then y to the 4th. So if I combine all my like terms, I'll have 16. X to the 8th times x to the negative 8th is x to the 0 power, which is 1. They basically cancel out. Y to the negative 6th times y to the 4th is y to the negative 2nd. So I could put y to the negative 2nd, but I want to make it a positive exponent, so I'm going to put it over y to the positive 2nd. Hopefully, going through those examples has helped you on this quiz, making your corrections. Remember that your corrections are due, and you have to not only write down what the correct answer is for each problem that you missed, but you have to write down what it was that you messed up. Hopefully by doing that, you will remember that those mistakes a little bit longer and then be less likely to make them in the future.